write the parametric equations for the line through these 2 points. So we know that if we're given 2 points, we can always write the equation of the line through those points. And, you know, since many, many years ago, you've done y equals mx plus b, right, or something like that. But now we're going to write the parametric equations. So I think it's easiest when you write the parametric equations to write the vector form of the line first. And the vector form of the line is going to look like this. Now, that's going to pop back up in the next chapter, believe it or not. You're going to see something very similar to this in the next chapter. But for now, we're writing the equation of the line. So, in this, anybody remember what goes here? It's a point on the line. So I'll just use the first one, but you could use that one. It makes no difference. This is a point on the line. And then this is the direction vector of the line. What this equation is doing is saying, okay, you have this point. Now, how do I move to get to the next point? Well, how do you move to get to the next point? 7, 3. So what that says is simply, if you start here at this point, and you go right 7 and up 3, you will be at the next point. And then if you go right 7 and up 3 more, you'll be at the next point, and so on and so on and so on. This is called the vector form of the line. You wanted the parametric equations? Well, that's easy. Just split it up. X equals and y equals. Those are the parametric equations. So what does x equal? X equals -1 plus 17, and y equals 1 plus 3t. That's it. That's all there is to it. Those are the parametric equations of the line. Okay? All right. Who else has something to talk about off the review sheet? Aiden?
Well,
Have you tried it, Aiden? I don't know where to start. Well, first of all, we got to put an I in there. I left an I out. That's probably what confused you. What do I have to do? My job is to solve for z. I need to square root it, right? And square rooting is what power? 1/2. So I'm going to have -1 plus root 3i to the 5/2 power. Now, you could do this in 2 separate stages. You could raise this to the 5th power, get an answer, and then raise that to the 1/2 power. But since de Moivre will work with any power, fractions, negatives, whatever, we'll just do it in one step. We're going to raise this to the 5/2 power. Okay, so if I'm going to use de Moivre, what do I have to do? I got to get it in polar form. So we've been doing that all day, it seems like. So my radius is 2. And my angle is, well, how big is that guy? 60. So my actual argument then, theta in standard position, is 120. And that's the number I'm going to raise to the 5/2 power. Everybody okay with that? Okay. So now I do it. So what does de Moivre tell me to do?
Raise the
2
2 to the power.
to the power. And then the angle times the power. 300. How many answers does this problem have?
2.
Why does it have 2 answers?
Square root.
Because it's a square root. The 5 doesn't have anything to do with it. The root is what gives you multiple answers. So, how far apart? If there's only 2 of them, how far apart are they? 180? Well, what's gonna happen if I add 180? I'm gonna be too big, so why don't I subtract 180? Will that accomplish the same thing? So that's gonna give me 120. Now, if you add 180, you're gonna get 480, and when you shrink 480, you're gonna get 120. So either way, you're gonna end up with 120. Here are my answers, and they are in polar form. But the question said answer in complex form, which means x plus yi, right?
Yeah.
So I have to find x. Well, let's clean this up first. What does 2 to the 5 halves mean?
Square root of 2 to the 5th.
Means the square root of 2 to the 5th power, which is root 2 times root 2 times root 2 times root 2 times root 2. 2 times 2, so 4 root 2. So r is 4 root 2 cosine cosine 300. And y is 4 root 2 sine 300. Now, doesn't say exact, but it doesn't have a star next to it either. That means it's on the no calculator part. So we need to do 300, which has a reference angle of 60. What's the cosine of 300? 1/2. So that one's just going to be 2, that one's just going to be 2 root 2. And then the sine of 60, that's going to be minus, 2 root 6. Because I got to multiply a root 2 times a root 3. And there's my first answer in complex form. Now, I need to do the same thing with the second one. So that's going to be 4 root 2 times the cosine of 120, and 4 root 2 times the sine of 120. But we've made this observation before. I want you to understand it only works with square roots. But because square roots are 180 degrees apart, this one's in quadrant 4, I'll be moving into quadrant 2. So that answer will be negative 2 root 2 plus 2 root 6i. If you are at all confused about what I just said, then work it out. Work it out. And you will get that. All right, anything else from the review sheet? Colin?
17.
Have you tried these, Colin?
Yeah.
We have a car parked on a street making an angle of 14 degrees. So here's the car. It's a 2,800 pound car. And find the force needed to keep the car from rolling down the hill. So I think in the notes, I think this was a guy on a sled or something. So pretend you're like a big, strong person. And your job, you're standing right here, and your job is to pull that car so it doesn't roll down the hill. So we're finding the force that would take. So I'm going to go ahead and drop that down, straight down. That's 2,800. That's the gravitational pull of that car. And then I'm going to go ahead and construct a right triangle here. And this is the force that I need to counteract. this is the force pulling on the car down the ramp, and then it's gonna match this over here if I'm gonna hold the car in place. Do I know anything about that little right triangle that I drew there? Do I know anything about it? If I dropped this all the way down, which I'm not going to do, but if I did drop it all the way down, would you be able to find this angle right here? Wouldn't that angle be 76? Which means this angle is 14? Now, you know the hypotenuse is 2800. You're looking for that. If you use 76, you'll say cosine 76 equals x over 2800. If you're doing sine, you'll say sine 14 equals x over 2800. Either way, you're going to get the same answer because of the co-function relationship. So the answer will be, make sure I'm in degrees, I am not. 2800 cosine 76. I got 677.38 pounds. That's the force I would have to be pulling with to keep the car from rolling down the hill. Okay? Anybody else from the review sheet? Mr. Keller?
Number
14. Okay, this was on our quiz. It was also in our homeworks. We've done this problem a few times. What's the plan? What's the strategy? We got the plane, we got the wind. What do we have to do? Well, we gotta find the components of each vector. So we'll find the x and the y for the plane. And we'll find the x and the y for the wind. And then what will we do with those? Add them together to get the components of the resultant. Right? So here we go. X equals r cosine theta. Our problem is 14. So here's my airplane. I think a picture really helps. On a course of 190 degrees. So that right there is 190 degrees. Navigational heading. And its magnitude is 331. So the components of the plane are going to be 331 cosine, 331 sine. And now I just need to find the angle in standard position. So what do you think? What's that red angle going to be? 260? Remember, if that's 190, this would be 10 right here. So all the way around to here would be 270, but we only went 260. Perfect. All right, then we got the wind. And the wind is a course of south, 17 degrees east. So there's the wind, and its magnitude is 28. So 28 cosine something, 28 sine something. And the something is the angle in standard position, which would be 287. So now I'm going to add them up. So am I in degrees? I think I am. All right, so 331 cosine 260 plus 28 cosine 287. So negative 49.29. I'm finding the components of the resultant. Oops. That is not the answer to the question, because the question didn't say, find the components of the resultant vector. What the question said is, what's the magnitude of it, and what is its navigational angle? That's what we're looking for. So if we draw a picture of this new vector that we just got, over 49.29 and down 352.75, then this would be its directional angle, right? That would be its direction, its navigational heading there. So how do you suggest we figure out that? Second tangent, of course, we always second tangent. 352.75 divided by 49.29. Now, that's this guy. I don't really want him, so I think I'm going to do 270 minus him. You could do it other ways, but you got to end up with 187.95. That's his direction. Now, his speed is the magnitude of this vector right here. So we find magnitude by squaring the first one, squaring the second one, and adding them up, and taking the square root. I got 356.18 miles per hour. Right? That problem was on our big quiz we took. It was also in the quiz review and also in the homework. So you got plenty of practice if you need to practice that. So there's some in the notes too. All right, anything else from that before we take one last look at our homework? Anything else from the review sheet? All right, let's look at our homework then. I just passed back some homeworks. We didn't go over those, right? So do we have any question from the homework that we need to look at? The homework that I just turned back. Some of you just got back paper. I put the homework answers in this morning. So forgive me if I've already said this. I can't remember who had told me. If you are one of the people who turn your homework in electronically, you better be checking to make sure, because I don't physically grade your paper. So I haven't marked things wrong on your paper. So you probably missed a thing or here or there. So check your work with those answers and make sure you've got it figured out. Anybody who did get a bunch of check marks on your paper have a question about it? Aiden? On which homework, Aiden?
6.6.
6.6. Number 5 says find the cube roots of this number. Okay, so what do I need to do first? Aiden?
No, that's
number 4.
Oh, I'm sorry. Oh, well, 5, we just did one just like it.
That's the
We just did one exactly like this. It says solve for A. So what are we gonna have to do to get A by itself?
the power of 3
We're gonna raise both sides to the 3/2 power. So now we have negative 2 root 3 plus 2i to the 3/2 power. Did you see, Aiden, what you're supposed
I
to do?
solved it like the past problems. I thought I was supposed to get 3 answers.
Well, we don't get 3.
Yeah.
How many do we get? 2. Yep, we get 2 answers to this. So we're gonna change that into polar form. So it'll be 4 for CIS, let's see. This angle's 30, so my argument's 150. And then what does Demov say to do once I have that changed into polar form? 4 to the 3 halves, and 150 times 3 halves. That's my first one. What's my second one? Well, how much different is it gonna be? 180. So 45? 4 to the 3 halves is 8. What does 4 to the 3 halves mean? Square root of 4 cubed? Might have to do that without a calculator. You can do it. Now, these are the polar form answers. What am I supposed to do? Answer in complex form. So 8 cosine 225, 8 sine 225. Has a reference angle of 45. So the cosine is negative root 2. Negative root 2 over 2, so I got negative 4 root 2. The sine is also negative 2, so negative 4 root 2 minus 4 root 2I is answer number 1. Again, this is a square root problem, so you can shortcut it. What's the second one going to be?
42 plus
4 root 2 plus 4 root 2I. There are your 2 answers in complex form. All right. Anything else from the homework we need to look at? Okay, juniors, some of you may be interested in